Hello all, welcome to my channel Simple Concepts by DJ. Today we are going to discuss about the topic called as Joules law of electric heating. Okay, this is the topic. So I'll write the topic in the board. Joules law of electric heating. Joules law of electric heating. Okay, this is the topic that I'm going to discuss today. See, for example, what I'm going to do is let us consider a circuit. In that circuit, a resistor element has been connected. Okay, let us assume that a resistor element has been connected in the circuit. Uh, See, this is a resistive element. It is connected with the AC circuit. Okay, so this is a resistive element of resistance value R, and you have a current that is flowing I. I is a current that is flowing through the resistor of value R. Okay, this happens in a time of t seconds. T seconds. Okay, so if this is the case, so at t seconds, you have a current is passing through the resistor. Okay, so in order to maintain the current, you need to apply an external work. A work should be done in order to maintain the current, okay, at a particular level. Otherwise, the current keeps on fluctuating. The value of the current keeps on fluctuating. So in order to maintain the value of the current, a work should be done. Okay, so let us assume that WD be the work done. So you need to do a work done in order to maintain the current which is flowing through the resistor R in a time of t seconds. Okay, so this is called as work done. So for this work done, you have an expression. So that is, let's get into the derivation part of this work done. So work done will be work done equal to I squared into R into T. I squared into R into T. The unit of work done is joules. Okay, so the unit of work done will be joules. Joules. So I squared RT joules. This I squared RT joules I can also further simplify into I squared can be written as I into R into T. That is joules. So I have I into I. I'm just expanding the I squared as I into I, and it will be I into R into T joules. So now, which is equal to, according to Ohm's law, the voltage developed in the circuit is nothing but the product of current and resistance. So similarly, this is the product of, this is the current and resistance. This is a product. So I can substitute V in place of I into R. So that will be, I'm taking here V, this I am putting here I into T, VIT joules. See, from this expression, I can get several expressions, several sort of expressions. Everything will convey to this work done. Okay, so this I square RT joules, let it be equation number 1. This VIT joules be equation number 2. Then this VI can be expressed as W. W is nothing but the power. Okay, so I'm assuming capital W as power. So VI is power W into T. This is also expressed in the unit joules. So this can be considered to be equation number 3. So WT joules. Now I'm considering the equation number 1. From equation 1, I have I squared into R into T, which can be written as this I squared can be written as I equal to V divided by R, the ratio between voltage and resistance according to Ohm's law. I can be written as V by R the whole squared into R into T into R into T. So which can be written as B squared divided by R squared into R into T. So R gets cancelled. So you'll be left out with B squared divided by R into T. T, which is nothing but joules. So the unit of work done will be joules. So this is, let us assume that this is equation number 4. So this is also work done. So this work done has 4 different set of equations. I have formed 4 different set of equations. So everything resemble the amount of work done in order to maintain the current to flow through that particular resistor in a time of t seconds. Okay, so this is the expression for work done. Then in this work done, we are now going to see about a a parameter called as the mechanical equivalent of heat. Okay, the mechanical heat equivalent of heat. So for that, see, when a current is passing through the resistor, there will be a heat will be generated. Normally it is a normal practice. When a current passes through a resistor, okay, heat energy will be expelled. Okay, so that heat energy, that is called as heat produced. So we have a formula for that as heat produced. Heat produced, heat produced, heat produced, that is, I am indicating it with H. Heat produced H is equal to the ratio between work done, that is work done, and the mechanical equivalent, called as the mechanical equivalent of heat. What is this mechanical equivalent of heat? It is called as, it can be referred as mechanical equivalent of heat, or it can be also called as Joules constant. Okay, so this is called as the heat produced is nothing but the ratio between work done and the mechanical equivalent of heat. This mechanical equivalent of heat is being indicated by the letter capital J, because it is called as Joules constant. So it is denoted by the letter capital J, right? So what is mechanical equivalent of heat? So we know that 1 calorie equal to 4.18 joules. So what does it mean? See, this calorie, see, 1 calorie is the heat energy that has been produced. Okay, this heat, 1 calorie, you are having 4.18 joules of energy is there. That is the meaning of this. 1 calorie is equal to 4.18 joules. Okay, so similarly, what will be the mechanical equivalent of heat? So J will be nothing but work done divided by the heat produced, right? So this expression says that 4.18 joules per calorie. Okay, joules per calorie means for 1 calorie you have 4.18 joules. So mechanical equivalent of heat, that is J, equal to work done divided by this heat produced. This is heat produced. Okay, this is heat produced. So work done is WD, heat produced is H. So work done will be expressed in joules. This will be expressed in the unit joules divided by heat produced will be expressed in the unit joules divided by joules divided by calorie. This is how it will be expressed. The mechanical equivalent of heat is nothing but joules divided by calorie. Right. So now this is the expression. Okay, this is the expression that we require. So now what we are going to do is we are going to take this equation. So the first equation is heat produced equal to work done by mechanical equivalent of heat, and in the second case mechanical equivalent is equal to work done by heat produced. So work done is nothing but 4.18. This is 4.18 joules divided by what is the heat produced. The heat produced is nothing but 1 calorie. It is 1 calorie. The heat produced is 1 calorie. Therefore, the mechanical equivalent of heat is equal to 4.18 joules divided by 1 calorie. Okay, so this will be only calorie. Okay, this will be calories. So 4.18 joules divided by 1 calorie. Now I want this 1 calorie to be expressed in kilocalories. So if I want to express it in kilocalories, it will become J equal to, that is the mechanical equivalent of heat will be equal to 4.18 joules. That is 4.18 joules divided by, when I convert 1 calorie to kilocalorie, I need to divide by 1000. So that will be 1 divided by 1000 into 1000 kilocalories. So this is nothing but 4.18 into 1000 into joules per calories. So this will be 4.18 into 1000 divided by into joules divided by kilocalories. Kilocalories. So 4.18 into 1000 will be 4.18 into 1000 will be 4180, which is equal to 4180 joules per kilocalories. So the value of the mechanical equivalent of heat is nothing but 4180 joules per kilocalories. Now what I'm going to do is I'm going to do an approximation and I'm going to write it as 4200 joules per kilocalories. This is the approximation. So J equal to, the value of the mechanical equivalent of heat is nothing but 4200 joules per kilocalories. Okay, so I got this value here. So now what I'm going to do is I have this equation, work done by the mechanical equivalent of heat. So what is work done? So heat produced, this is let us assume that this is equation number 5, just for indication 5. So heat produced, we are going to calculate the heat produced. So heat produced is nothing but the ratio between work done and the mechanical equivalent of heat. So work done, so the heat produced H will be work done. What is work done here? Work done can be taken from this formula. You can take this equation 1, because work done is equal to I squared RT, right? So H is equal to I squared into R into T divided by the mechanical equivalent of heat. We know the mechanical equivalent of heat is 4200. This I squared RT is expressed in joules. Okay, this is expressed in joules divided by the mechanical equivalent of heat J is 4200. 4200 unit is joules per kilocalories. So now what will happen? This will become I squared into R into T divided by 4200, and the unit will become, this is joules. When it goes to the numerator, this kilocalories will come to the numerator and joules will come to the denominator. So joules and joules will get cancelled. So you are left out with kilocalories. Kilocalories. So H is equal to the heat produced is H equal to I squared into RT divided by 4200 kilocalories. So this is one way of finding the heat produced. Again, in this second equation also you can substitute. So H can also be written as VIT joules. So V into I into T divided by 4200. 4200 joules per calories. So the unit will be kilocalories. Okay, so this is one type of heat produced. Okay, and also you can use this formula also. So this formula is H is equal to H equal to H is equal to, here you have another formula, W into T. Okay, the power into time. Okay, that can also be expressed as heat, and that can also be expressed as work done. So H is equal to work done, that is a W into T divided by 4200 kilocalories. Okay, that can be expressed as WT divided by 4200 kilocalories. This is one form of expressing the heat produced. And the final thing is you can use the work done equation, V squared T divided by R. So H will be equal to V squared, V squared by R into T divided by 4200. So this will become V squared into T divided by R into 1 divided by 4200 kilocalories. Okay, or you can just write this as H equal to V squared T divided by 4200 R kilocalories. Okay, so this will be the value of the heat produced. So from this work done, you can form three different type of equations, and you can substitute all the different type of equations with the formula, that is heat produced. So you also have heat produced. You have four different 1 2 3 4 5 different type of equations you can form here. I mean, four different type of equations you can form here. Okay, based on because you have work done value is different in every set of equations. The value keeps on changing. So similarly, as the value keeps on changing, the heat produced, the value in which the heat is produced, the heat produced value also will keep on changing. So these are the heat produced values. Okay, so you can substitute in the formula and you can get the result. Okay, when different parameters, like sometimes they will give current, resistance and time, sometimes they might be giving voltage, current and time, sometimes power will be given, sometimes you will be getting voltage, time and resistance. So based on the requirement, you can use any one of these formulas and you can solve the problem. Okay, so this is what is called as Joules law of electric heating. Okay, this is just a conversion of one unit to another unit. Okay, and we are seeing what are the different possibilities that are being involved in this Joules law of electric heating process. Okay, thank you all for watching this video. Please do subscribe. Thank you.